The graph of the function f is shown above. Which of the following statements is false? So using this graph of f, we need to find out which one of these statements is not true or false. So A says limit as x approaches 2 of f of x exists. So if we look at the graph at 2, we see that the limit from both sides does exist. In order to determine whether a limit exists, we just need to look at the graph to the left and to the right of the point of interest. So here, as we approach x equals 2, the graph from the left approaches y value of 2, and the graph from the right approaches a y value of 2. Since the left and right limits exist, they both approach the same number. That means that the limit as x approaches 2 of f of x exists. Even though there's a hole here, the actual value at x equals 2 does not matter in order for the limits to exist. All that matters is the graph on the left and the right have to both approach the same thing. In this case, they both approach 2. So the limit as x approaches 2 of f of x does exist. So this is true. B says the limit as x approaches 3 of f of x exists. So x equals 3 is here, and on the graph, x of 3 is 5. And to see if the limit exists, we will look at what the graph does to the left and to the right of x equals 3. From the left, we see that this graph is approaching a y value of 5. And from the right, we also see that this is approaching a y value of 5. So that means the limit of as x approaches 3 from both sides, from the left and from the right, both approach the same thing. So that means this limit exists as well. And then what about C? C says the limit as x approaches 4 of f of x exists. So x equals 4 is here. We see that from the left, the limit approaches a y value of what seems to be a little less than 2, so like 1.8 or something. But then from the right, as the graph approaches an x value of 4, we see the graph on the right approaches a y value of 4. So the left and right limits are not the same, meaning they do not approach the same y value. One is approaching 4 from the right, and the other is approaching 2 from the left. So that means this statement is false. The limit does not exist. So this is likely the right answer, but let's check the rest as well. The limit as x approaches 5 of f of x exists. So if we look at an x value of 5, as we approach 5 from the left, x equals 5 from the left, we approach a y value of 6, and from the right, we approach a y value of 6. So the left and right limits both approach the same y value. So B is also true. And then the function f is continuous at x equals 3. So at x equals 3, which is right here, we see that the graph is continuous. Why? Because there's no holes or jumps at this point, meaning there's no holes like there is at x equals 2, and there's no jumps like there is at x equals 4. And we can also check for continuity by seeing if we can draw whatever is at x equals 3 without lifting our pencil. And indeed we can. We can go from x equals 2 through x equals 3 and further to the right without lifting our pencil because there's no jumps or holes. So that means the function f is continuous at x equals 3. So every statement except C was true, because at x equals 4, the left and right limits are not equal. So C is the correct answer.